So usually the link should not take you here. The link should take you directly to the presentation. So this is the web map. And so usually we see it like this. So it has all the it has the legend. If we wait a little bit, the data will the data appears. But this is not as interactive as the presentation. So
that's okay.
Just, go back to the presentation, because I like the fact that we can just click and it moves. So yeah, the context was finding where are the next best locations for a franchise to open up. That franchise sells a commodity, so people are not going to travel a long distance to get there. So the location is critical, and they had a strategy to open up their new stores, which was to outsource this strategy. And after 3 weeks, they only had of their contractor only found 6 locations. So it was not a data-driven approach. It was a best guess approach. So looking at transport hubs and where things would be probably good, but it was not a data-driven approach. So there was no facts, no figures to assist in the decision making. So with the data-driven approach, we'll understand from the data for all of these locations. We'll understand what's good, what works not as much, and we will apply this knowledge to the entire country to understand where it would make sense to open up new stores. So the complete data set takes into account lots of points. You see that there's lots of icons appearing. It's about 1 million points, and actually it is slightly more if we take into account all the data for transport hubs, so bus stops, metro exits, and so on. So the idea: how do we solve the business challenge with all of this data? Is by looking at the existing data, and we're going to look at the surrounding area for each location. And in the surrounding area for each location, we're going to create indicators to count the number of competitors, the number of transport hubs, so the bus stops and so on. We're going to make those indicators quite granular. So if you're selling coffee, we're going to count the number of Tesco's, the number of Costa Coffee, the number of Starbucks. And if you're vending sandwiches, the number of direct competitors and also indirect competitors, such as number of bars, number of hotels. We don't exactly know how at first, we don't exactly know how each indicator contributes, but machine learning will help us to sort out the mess and just tell us this is relevant, this is not. And if something is relevant, we can iterate and add more indicators on it. So here, some business knowledge is also very important, because and some common sense, because of course, if we're selling sandwiches, the number of competitors will be important, but it has to be put into a context. So if you have 10 times the population but only one direct competitor, then having one competitor is just not, in this case, it's a good thing. So we have to not only to compute those indicators, but we have to make ratios and cross-reference those indicators to understand really what makes a good location. And from what you're seeing here, if we so the legend does not appear, but I think green is number of bars, blue is number of convenience store, and if I just zoom out, we'll see that those indicators vary greatly from one place to the next. So here you see there's lots of yellow. Sorry, yellow is the restaurants. So the locations are not uniform. So here, yeah, there's a lot more. It's more dense in terms of shop. So we have to understand what's good, what's bad, and the way we do it is by computing the same indicators for all the shops, and then using the sales data, so either the net sales or the margin, we're going to use the internal data with all of those open source data, and we're going to try to explain the sales data with all of the other indicators.
Yep, and create the business rule based on that rather than just being dictated by business.
Yeah, letting machine learning infer the business rules. Tell us what is influencing. If there are some location aspects that are not as straightforward as the number of buses or the density of population, we could also compute those. This is what you see here are the stains that have appeared. Those are clustered areas with shops that have poor hygiene scores. And you often have a street with lots of greasy fast food, and that might not be reflected in the indicators if we simply count sandwich shops. So we also use another feature, which is aspherical clustering, to understand if those shops are located within one area that has a high density of stalls with poor hygiene scores.
So what you're saying is that the negative bias given by this particular data point is negated in some way by our technology? So is that what you're saying?
What I'm saying is that in the real life, customers will look at your surroundings, and you have good neighborhoods and bad neighborhoods, and the density of population or the presence of bars does not explain it all. If you have 20 fast food and 20 bad fast food, this might influence also the sales data. So here, this is just a more complex indicator, but this is just one other indicator. Mm-hmm. At this stage, we're not presumpting of what the outcome will be. We're just bringing data that we think is relevant, that we think might influence the sales. We're just constructing and preparing the data set.
Okay.
So what happens ultimately is we get, and this is not displayed in this map, but we get a model that is telling us for each indicator what's its influence. Is it a positive influence? Is it a negative influence? And a weight. And this is the hidden slide that you had in the presentation, where we see, for instance, the number of stalls, where from 0 to 3 it has a positive influence, and above 3 above 3 convenience store within 50 or 100 meters, it has a negative influence. So that's all the insights that the model that the predictive model is telling us, and there is no prediction at this stage. It's just descriptive analytics.
Yes, and you can use any extra data on the fly, right? So if the business tells us that we want to use, I don't know, average reviews into consideration as a text data, or we want to use weather data to start understanding if ice creams are selling more in particular places or suntan. I don't know. It could be any data, right?
Yeah, I've simplified it, but the fact that most of those indicators are computed on the fly, it enables them to just it enables me to or them to just have those indicators generate automatically. So, for instance, we didn't know for a supermarket whether the strongest influence is if it's 50 meters, 75, 100, 200. So we generate all of those indicators, and we see which we see. I mean, we let descriptive analytics tell us what's relevant and what's not.
Yeah. Yeah, no, that's just great. There are two indicators for restaurants which I don't think anybody takes, which is real estate price, as well as you know, the wallet share of people. Do we take, because you know, it might just recommend that you open a store just opposite Buckingham Palace as the best location, but it might be, I don't know, too expensive and unprofitable hence. Yeah? So maybe that's a lag indicator that we have to take as well. But you know, I'm not advising on the demo. I'm just commenting that we can take any type of data in the future.
Yeah, and demographics play the dynamics of demographics also play a big part. I mean, if you have offices and only offices, your revenue in the evening will plummet because people go home. So those dynamics, are also important. In this situation, we did not include that. We did not include the data, but the results after just 1 week were quite good. The models were accurate, and with those information, that takes us to the next step is we can project it, and we can simulate, and we can run all of those what-if analysis. So if a competitor is open, will it tip the balance from profitable to losing money? And that's also that's a risk you have to take into account if you set up shop somewhere, but and you gain just a little bit of money, but suddenly if Starbucks, which is not in the area, opens, you will lose. Then this is another information that you need to take into account. The other interesting thing is, given the sheer power of Hana, we can just apply that knowledge to the entire country, and this is what's happening here. For the millions of points, we group them by location, and we apply the prediction of sales for this particular location, given all of the attributes. And the darker it is, the higher the sales.
Yep.
And when there is not even an hexagon cell, it means that it's too bad to be even considered.
So we already see some stores in those bad areas already, yeah. And if we can cross-check if they are the ones which are not profitable.
Exactly, but that also shows that the way they grew was not it was either not data driven, they had some other growth strategy, or it could also mean that there is information that is not taken into account in the model. We don't hold the golden truth, but there could be other information not taken into the model. But what's very likely when we see shops set up in empty spaces is that it was strategic. It could have been to push out or to take a spot and not give room to the competition. I don't know, but yeah, it's very likely that in those empty spots, those stalls are not making money. And of course, there could be outliers, But we're looking at the big picture here. We're looking at strategy decision. So yeah, if one particular shop is an outlier, that doesn't make the rule true.
Got it.
And so at any point in time, you can move the map, you can zoom out, and
so this
all of it
is hexagonal grid clustering from Hana.
This is hexagonal clustering happening in real time. It's in North America, so that explains a little bit of the latency. But this is recomputed for the.
You mean the data is in North America?
The data is in North America, and this website is.
Yeah.
Because of course, ArcGIS is co-located with Hana Cloud.
Okay, so once you finish this, so this is brilliant. Could you also explain a bit of the architecture and also tell us that I understand Hana Cloud, ArcGIS are sitting on each other, but why are we not using something like data intelligence, for example, to gather all the data in real time?
Because this data is, I mean, we could. This was loaded one shot.
Yeah. No, all I'm saying is that if this is to be a continuous process for a company to get streaming data and throw it there, they could use data intelligence, right?
Yeah, absolutely. And that could be another sales play, but the way the data was populated was using a Python script.
Oh, okay.
And that Python script is just downloading data from the Open Data portal.
Yeah.
And putting it in tables, but this
is available within Data Hub.
Exactly, which can be scheduled, which can be monitored. If it fails, I want to be notified that that something has failed. But the developer that made this this Python script might have other things to do. So yeah, when it comes to the productization of various data crawling scripts, Data Hub is a very interesting platform.
Yeah, data intelligence, as we call it now. Yeah, true.
Yeah, data intelligence, because it might come from APIs, it might come from those crawling scripts, but it all has to be, first of all, developed, but to be productized, the developers have to hand it over to the operations team, and the operations team has to look after the scheduling, the error monitoring, and so on.
Of course. And correlating it with the cost of opening a bad store and closing it down in a year, I think pays many times over for something like this, right? Because I understand what I know about the kind of business is that it takes, I think, around 100 to 200 days to plan, execute, and build and fit out a new store. And then if it fails in a year, the total cost of that goes into millions, right? Just one store going wrong. So that's a big thing, and what it does to the brand and the experience of the customer base is also a big thing. So brick and mortar is not an easy thing to decide, but yeah. But tell me, restaurant or retail opening up in high street is probably going to be a reverse trend going forward, but this can be applied to any type of business, right? For example, I'm thinking insurance. This could be a risk model approach for calculating healthcare premium risks like we did in AOK, right?
Yeah.
Similar type of approach, right? So different types of data, proximity, and then looking at hotspots for different type of risk scores.
Yeah, and I mean, in terms of city planning, we've also seen that behaviors are shifting. A lot of people with a secondary home are using it outside the city, are using it a lot more, and that has been the case for the last 6 to 7 weeks, and that might be the trend going forward. Yep. So that means that you will have to adapt what you knew to the new reality. Your model, your predictive models have to be updated. If there is no automation in that process, you're going to have to give up on other topics so that you pursue something which is technically simple but time-consuming, which is refreshing the predictive models and re-ensuring the quality. If you haven't made this investment in ML Ops, machine learning operations platform.
Yeah, you mentioned that this ArcGIS platform is on Hana Cloud.
So ArcGIS is running in AWS. We don't host it ourselves, but the data is in Hana Cloud. Simply because it is the cheapest option to store a small data set.
But as well as the raw power and the advanced analytical native integrated advanced analytics that is providing, right? You can't do this in anything else.
Well, you could do it with Hana on premise.
Of course.
Here, I'm just using it for the ease of use. I don't have time to maintain the infrastructure, update it, and backup it, so on. But also, it's for those innovation use cases. The cloud version is always ahead of the on-premise releases. So I get the best. I get the features when they come out, and which is every 2 weeks. And not every 8 months, every year it will be every year going forward.
Excellent. No, that's been very helpful, Remy. Thank you so much. Let me stop.
No worries. I know you'll make it yours anyway, but